Hello, fellow solvers. This is Cog with Cog Analytics, jumping back into the Alteryx discussion board, answering your questions. So today we're looking at not really tabular layout posted by Kevin D. So the question is not as easy to read. I think this data would have been better served in an Excel spreadsheet attached to the question, but it is clear enough, I believe, to bring forward a good and interesting question is how do you take hierarchical data, nested data that looks like something like this, and normalize it or flatten it out into a more tabular structure that you can actually do your analysis on. So we'll jump into, well, before we jump into Alteryx, I did again build a custom tool or macro tool that is in the gallery as of right now. It will be, the link will be posted in the description. If you think this would be beneficial for you, or you have a use case that you need to normalize or flatten your nested data, go ahead and check it out, go ahead and download it, and hope it can be useful for you. So we will go into Alteryx, and first things first, we're going to approach this generally. So we're not going to answer directly the original poster's question or use his data. We are going to use our own sample data. And again, once we build this out, it will be a general workflow that we can apply to whatever use case we would like. So we can see our input data here. We have number, letter, and numeral, and it is in that exact hierarchical structure where each cell is related to the cell to the left and as far up until you get to the next corresponding element. So A is related to 1, Roman numeral I is related to A, which is related to 1, 6 to C to 2, D and 4, 3 doesn't have anything associated with it, so it stands by itself, and so on. So one of the first things too, I guess, before we start building this out is there are a lot of empty cells. And this is one of the first things we're going to tackle in terms of solving this problem is removing all of this dead space. And this will collapse things down and actually give us that first tabular structure. And then we're going to do a second pass at the problem, doing a very similar structure and actually a good example of how sometimes doing very similar process twice can get your data into the format that you actually need it in, whereas trying to come up with one clever way to do it is going to be much harder, much more of a headache. And again, before we dive into our workflow, I do want to say that one of the ways that you can handle these types of problems is with a bunch of multi-row formula tools. So you can cascade down each value with the multi-row formula tool, then use another one to do the next column, another one to do the next column, so on and so forth. So for a problem like this where there's only 3 columns, that could very well be your solution. But as I said, we want to approach things generally. We want to build things in a smart way. So in order to handle this, the first thing we're going to do to get rid of all of these null values is transpose the data. That way we can do it all at once. And I guess before we transpose the data, let's add a record ID so we can keep track of where we're at and build our original data set back. So we have a record ID and we're going to transpose group on that record ID. And if we run that, we can see we now have one large column containing all of our values, and then obviously keeping track of the columns as well. Perfect. So the next thing we're going to do is we're going to add a tile tool. This way we can track the column order as well. So you can see here we have a record ID, but now it's broken up. There's redundancy so that we can identify all of the records that are associated with a single record that we originally had. But we want to keep track too of each of these columns independently. So the tile tool is a good way to do that. Ultimately, we only need one column, so we could use the multi-row formula tool here. That's actually something I'm rather fond of using. But in this case, the tile tool is a much simpler way to go. It's just one tool. We don't have much in the way of configuration we have to take care of. So we will look for unique record ID, and that is all that we need to label our columns. So the tile number is, again, this is the redundant information we have. It's exactly the same as record ID, but we can now see the tile sequence number gives us our column identification, our column indexing. So now we can get rid of all of these extra null fields that we have, our null values. To do that, we'll add a filter tool, and we want to keep all the values that are not null. Once we've done that, we can add a multi-row formula tool in. What we're going to end up doing now is re-indexing our record ID. So you can see we have each value now. We've removed all of the nulls in the data set. But our record ID now is completely unique. It's a perfect index of this data set. But what you can see here is we have a number, a letter, and a numeral. So we have right here our very first record. This is exactly the structure that we want to see just pivoted or cross-tabbed in columns. So we'd like to convert this into what we had before here, where the record ID is capturing all the record information. So in order to do that, we can go to our multi-row formula tool, and instead of creating a new field, we're going to update the record ID. You don't need to group on anything, because the way that we're going to do this is if you take a look, our tile sequence number, again, we're tracking the columns. We have column 1, column 2, column 3, and we have column 3 again. So this tells us that we're jumping into a new record, and every time this value is either the same as the previous or smaller, then we're resetting to a new record. So we have this is a record, this would be a record, this is 2, so it's smaller than 3, that's a new record, so on and so forth. So we're going to build that out with the multi-row formula tool, doing exactly that. We can add an if statement. If the current tile sequence number is smaller than or equal to, less than or equal to the previous one, then in this case, I know that we are in a new record. So we're going to add 1 to the previous record ID. Otherwise, we will keep it exactly the way it is. I'll leave it here. And just repeat the previous record. So you can see here, we're trying to re-index the list and either incrementing from previous or keeping the previous. And that way, once we run this, we can see we have everything now grouped nicely into our record groups we had originally. Although in this case, it's on the data set where the nulls have been removed. And so you can see exactly as we described, that first 3 records correspond to one single record in our unpivoted data. Then we have just a single record, then we have 2 records. And we can go ahead and take a look at this now with the crosstab tool. Before we do that, let's add a sort just to make sure that we're not losing track of anything. We'll sort by record ID and the column number. We want to group by record ID. Column name is name and value is our value. Okay. Oh, we're going to add one more sort. Perfect. And so you can see we have already a normalized form of the data. But what you'll very quickly notice is that we are missing most of the values. So all those nulls we removed have come back. But they're now reformatted so that each value is now all condensed into a single record. So instead of having large chunks of nulls, now we have records with missing values. So now all we need to do is cascade the values down to fill in what's missing. In order to do this, we're going to actually add in a couple tools a little bit earlier in the workflow so we can keep track of how many columns of data we've filled in. So to do that, we are going to remove this connection, add a summarize tool, and join that back in, and we will configure that next. So if we take a look at the summarize tool, we have the record ID gives us a record group, and what we want is to know what is the minimum column that we have filled in. And if we join back in, and we'll take a look at the data, join on record ID, don't need the redundancy. Perfect. And then we want to make sure that we group on that value as well. Great. Okay, so now we're ready for phase 2, and we can see, so for each record, the min tile sequence number tells us how much data is filled in. So in the case of 1, we have everything up to the first or root column is filled in. In this case, we have the third column, so we can see there's 2 nulls, and the third column is the closest to the root that's filled in. And so this tells us exactly how much data we actually need to insert. So for a case like this, where we have 4D and then we have nothing, The D isn't associated, or there's no numeral associated with this record. We don't want anything cascaded down, so we don't want this 6 coming down through. We can see here all of the data we need is already present. So this record is done. And so this is exactly what we're going to use this column of data for, and you'll see that more when we get to it. So we will build out phase 2 or part 2 of this workflow. And again, so we're repeating a very similar process. We're going to start by transposing the data. Connect this up. So we'll transpose the data, but now we're going to group on record ID and that min tile sequence number. And immediately we're going to, kind of similar to what I said before, except now out of a desire to be efficient with the number of rows or columns that we have, I will create a new field. Instead of using the tile tool, we'll use the column num. And this is grouped by record ID again. So this is doing exactly the same thing as the tile tool does, except this will only add one column, and we have to do a little bit more typing to get it built out. So now you can see we have pretty much exactly what we had before. Obviously the sorting has been messed up, but we have whatever our min tile sequence was. You can see the null values, and we now have indexed the columns again. So now that we've done this, we're going to, as always, sort our data for AMP engine. But this case with record ID and on column num. And we're going to use another multi-row formula. So this is where kind of the main formula, again, you can see a transpose, we have a column indexing, and we have this kind of master multi-row formula tool that is doing the heavy lifting for us, again, in this part 2. So instead of creating a new field here, what we're going to do is, again, update, in this case, the value field. So we're cascading down and filling in all the values that are missing. So in this case, we want to do all records. Let's see where update is. We're going to update every record where the column num is less than this min tile sequence num. Otherwise, we're going to leave it be. We don't need to do anything if the value is not less than. So that's exactly what we're going to code in. Make sure we're grouping by the name so that each column of data is taken care of or handling itself, and we're not getting bleeding from one column into another. And we want to say if, just like we described, if the column number is less than the min tile sequence number, then in this case, we want to run our logic. And we want to check if the value is null. There we go. If the value is null, then we want to use the previous value. Otherwise, just stick with the value that we already have. Now, if that's not the case, as we said, we want to leave things be and don't mess with anything. That way we're not causing ourselves any problems. Add a sort tool to this. Sort on record ID again and column num. And we're going to cross tab. Doing exactly the same thing, except we don't need to group by the min here because we're getting our final output. Column headers are the same. It's name, values is value, and we want to aggregate as the first. And that's it. We can add our final sort just to make things look the way that we want them to on record ID, and we'll do a select to get rid of record ID. And that is it. If we run this, we can now see our data is in exactly the form that we wanted it. This is now flattened or normalized from that hierarchical form. All the values have been filled in. You can see here we have the number 3 has nothing associated with it exactly as we had in our input. We can see that here. Our input 3 has nothing associated with it. This is exactly what we were looking for. So, as always, hopefully this kind of gives you an idea as to how to structure. Again, recognizing sometimes it's better to do 2 passes, doing very similar things, or very similar workflow or process to convert your data from the form that you start with, input, to generate the desired output. You can either build this yourself as a challenge, or as I discussed earlier at the beginning of this video, you can go to the gallery at the link in the description below and download the Flatten Nested Data tool that I have posted there. It does exactly that. So this is the original poster's input data. You can see a lot more columns. We run the exact same workflow we just built, but now in one handy macro, and it does exactly the same thing, normalizing all of that data as we expected. Anyways, hope this helps. I think this was a good introduction into, again, doing multiple passes, dealing with odd formats for input data, and converting them to the desired output format, in this case, normalizing or flattening nested hierarchical data. Again, hope this helps. Happy solving.